A very good day to everyone. So today me and my teammates are going to present our DFC 30233 data structures mini project given by our lecturer Puan binti Azizan. So let me start off by introducing my teammates. So my teammates are Peter PAULRAJ, THAVARAJ, matrix number 01 DDT21F1152, and NAQIB IKHSAN bin KAIRUL, matrix number 01 DDT21F1099, and me myself, ARVIND, ULAKANATHAN, matrix number 01 DDT21F2071. So let me start off by presenting my question. So the question I've been provided is that suppose you work at a restaurant that uses a first in first out FIFO system to manage food orders. When a customer places an order, it gets added to the stack of orders in the kitchen. To handle the orders, you decided to use a queue linked list data structure where each node in the linked list contains a stack of orders for one customer. As cooks completes each order, they pop it off the stack, display it on the screen and prepare it for delivery to the customer. Write a C++ program to stimulate the process.
We have written a C++ coding. This is our C++ coding. So now, I am going to explain this coding. First, the necessary header files IO stream, stack and queue are included. Then, two structs are defined, order and not. Order struct represent an individual order with a name and quantity. Not struct represent a node in the linked list. It contains the stack of orders and the pointer to the next node. Third is the void add order. So, function is the void add order function is defined to add order to the linked list. It creates the new node and initializes it with an empty stack and a null pointer. It creates new order object with the provided name and quantity. If the linked list is empty, the new node becomes the head. Otherwise, it traverses to the end of the linked list and adds the new node. Then we head on to void process orders. So void process order function processes and displays the orders in the linked list. It checks if the list is empty. If so, it displays a message and returns. While there are nodes in the linked list, it iterates through each node. For each node, it retrieves the stack of orders and processes from them one by one by popping them from the stack. It displays the order details, name and quantity on the console. Then we head on to void delete linked list. So void delete linked list function is defined to delete the linked list and release the allocated memory. It iterates through each node in the linked list. It keeps a temporary pointer onto the current node, moves the head to the next node and deletes the temporary node. Then void get user input. Void get user input function allows the user to input orders interactively. It takes user's input for the order and the quantity in a loop. To exit the loop, the user can enter done as the order name. In the main function, it initializes the order queue head pointer to null. It calls the get user input function to get user input for orders. It displays message indicating the start of order processing. Then it calls the process order function and displays the orders. Finally, it calls delete linked list function to release the memory. So now we are going to present the output. So as you can see from the coding above, the output will be like this. So the order name will be Milo and the quantity will be 5. You can put anything in the order name and the quantity also. So let's say the customer ordered Milo, 5 quantity of Milo, then Maggi as many as 4 quantities. So after you entering the things that the customer ordered, then just type done, then it will display processing orders, then preparing order Milo quantity 5, then preparing order Maggi quantity 4. That's all from me for the question 1 coding. Now I'll pass the presentation to Peter PAULRAJ. Thank you.
Thank you, Arvind. So now I will continue this presentation. Let us see the question 2. You are organizing a convocation event for a polytechnic and you need to manage the students' records of those who will attend the event and receive scores. Each student record includes the student's name, track, network security and software, and the classes, which is the first class, upper class, second class and lower class, and also the third class. So basically, to efficiently handle and retrieve these records, you will use a binary search tree BST using linked list. Each node in the tree represents a student's record with the student's name used as the key for sorting the tree. And we have to write a C++ programming language that implements this data structure and provides the following functionality. The first one will be add a new student record to the tree. Second one, delete the student record from the tree, following by search for a student record based on the student's name. Then following by the count the number of the students, and last will be the print the list of students record in ascending order based on their names. So now let us see the C++ programming in the next slide. So now let us see the C++ programming for the question 2. So the code will begin by including the necessary header files, IO stream and string. Then continue for the student record stock, which is defined and representing a node in the binary search tree BST for storing the student records, and it also contains for the student's name, track, class rank, and pointers to the left and right child nodes. Then continue with the create student record function, which is defined to create a new node for a student record. It takes the name, track, class, rank as parameters to initialize the fields of the node and returns to the newly created node. Then continue to the fourth function, continue to the fourth point, which is the insert student record function. Now, this function is implemented to insert a student record into the BST, and it also takes the root of the tree along with the name, track, class, rank, which we can see here. Name, class, rank of the students to be inserted. This function recursively travels the tree based on the name, comparing with the current node. And if the name is less than the current node's name, it goes to the left subtree, otherwise it goes to the right subtree. And it continues to traversal until it finds an appropriate position to insert the new node. Finally, it returns to the updated row. Then the search student record, which is the function searches for a student record in the BST based on the provided name. It takes the root of the tree and the name of the search as parameters. The function performs a recursive search, comparing the name with the current node's name and traversing left or right until it finds a match or reaches a null node. If a match is found, the function returns the node, otherwise it returns a null, as we can see here. So then continue to the min value node here and the next function. This function is implemented to find the node with the minimum value, which is called as the leftmost node in a BST. It takes a node as a parameter and it traverses to the left child until it reaches the leftmost node. Finally it returns to the leftmost node. Then the next function, which is the delete student record. This function deletes a student record from the BST based on the provided name. It takes the root of the tree and the name. It takes the root of the tree and the name of the delete of these parameters. The function uses recursion to find the node with the matching name. Once the node is found, it enters the case. So in this delete student record function, there is two cases, which is the first case will be node as no children or only one child. In this case, the function adjusts the pointer and deletes the nodes, and for the case 2, which is the node has 2 children, and for the case 2, it finds the minimum value node in the right subtree in order successor and copies its data to the current node and recursively deletes the in order successor node. Finally, the function returns to the updated node. Return row. Then the next function is count students. Count students. This function computes the total number of students in BSc, and it takes the root of the tree as a parameter and recursively counts the students in the left and right subtrees, adding 1 for each node, and it returns the total count. And then the following function is display in order. This function performs an in-order traversal of the BST and displays the student's record in ascending order based on the names. It takes the root of the tree as a parameter and recursively traverses the tree in order, left subtree, current node, and right subtree. So it displays each student's name, track, and class rank. So then followed by in the main function, as you can see the main. So In this main function, the root of the BST is initialized as null. Then a loop is started to display a menu of options to the user, and following by the depending on the user's choice whether the corresponding actions will be performed. Then adding a student record, as we can see though, add a student record. So adding a student record by taking input for name, track and class rank. Then deleting a student record by taking input for the name to be deleted. Searching for a student record by taking input for the name to be searched. Then the fourth is printing the list of the student records in ascending order, and the fifth will be printing the list of the students records in ascending order. The fifth one will be the exit the program, and then the loop will continue until the user chooses to exit. So for this we have to choose a while and if. So for this part it will remain the same, but we have to change the sentences here. For the example, for the add student record, it have to be add enter student name, enter student track and all. For delete enter student name to delete. So for the first one it has only if, then the following will be else if, and we have to change the sentences as we can see here. So then after done all the invalid and all the process, finally the program returns to the 0 to indicate the successful execution. So now let us run this program and see whether it is correct or not. So yes, the program is run. And now let us type our input. So first we'll be adding 3 student record from 3 track. Kavi student track will be equal, and student class rank will be 1. Now will be my name. Here is the mistake. We have to enter the choice first, will be number 1, and now only we have to type the name Peter, student type security. Security. Then class rank will be 1. Enter your choice will be 1. Student name Akasha. Track programming. Then class rank 1. So now let us delete the student record. So for it we have to choose the number 2 option. So enter student name. I'll choose Akasha to be deleted. So yes, it says student record is successfully deleted. So now let us check by type 5. Let us see the print the list of the student records in ascending order. So it's supposed to be mine is if the print list, it's supposed to be have only 2 because Akasha is deleted. So now let us check. Yes, as we can see, Akasha's name also has been deleted, and it is in ascending order because K is before P, so it is correct. So this program is running correctly, and that's all for question 2. Thank you.
So for the next question is, based on the figure below, illustrate the step to find the key of 50 by using binary search method. So for the first we have to know which the first, the mid and the last of the key binary. So for the first one is 5, and for the mid one is for the first one is 0, and in the middle is 4, and for the last one is 8. So if you want to change the target key, which is 50, we have to eliminate the below of 50. So 50 is greater than 34, so we have to eliminate them, and then after eliminate them we got the target key 50, which is the first one is the 5, the middle one is 7, and the last one is 8. So yeah, that's it.
So that's all for our mini project presentation. Thank you. Have a great day.